Okay. So I think this is the model that we had where the demand curve is summarizing the behavior of the buyers, like the savers in our market, and the supply curve is indicating the behavior of the firms who want to borrow. And anytime, so at the equilibrium we get an equilibrium price for the bond and equilibrium interest rate. In the last class we established that the equilibrium price and equilibrium interest rate are connected because whenever the price of a bond goes up, the return on that bond goes down, so they are actually negatively related. So when we want to think about, if we sort of rewrite some of the terminology, and these are going to be important today. So imagine that we talk about BD is the demand for bonds and BS as the supply of bonds. The equilibrium will be where they are equal. We can also understand that when BD is equal to B is greater than BS, so we are talking about a situation where let's say the market price is like 50, like 750, and I have just found that this smart thing is kind of good. So I'm gonna try this. Okay. So what we have found is when the market price is less than the market price, like this one, right, and the demand, as you can see, is higher than the supply, which means that there are more people willing to buy these bonds than supply. If that happens, we are going to see an upward pressure on price. So price sort of creeps up from 750 to 800 to 850. Notice what is happening to interest rate. Interest rate is going down. Do we all see that? So one should be aware that there is this dual movement that we will always observe in our market. Anytime price rises to adjust to the market equilibrium, like the one we just saw, interest rate will start going, interest rate will start going down from 33 to 25 to 17. The opposite situation is going to happen when there is an excess. By the way, this is excess demand. I think it talks about excess demand. The one when the market price is 950, where you actually see an excess supply, it is going to put a downward pressure on the market price. This is just like what you saw in a market demand supply model, nothing fancy. The key thing to remember is that as the prices go down to adjust to market equilibrium, interest rate creeps up. So the point that I want to make here is that depending on whether the market is in excess demand or in excess supply situation, we are going to have different kind of movement in price and interest rate. But the most important point is that anytime the market demand is equal to the market supply of bond, it will reach an equilibrium where everything will stop. There will be no further movement unless something happens on the demand side or on the supply side, which we are going to look at right now. Okay, so the slide talks about that a little bit. Now let's spend a little bit of time trying to understand what happens to this market equilibrium whenever something either on the demand side or on the supply side changes. So what we are trying to understand is how does the equilibrium interest rate change? Because we are now going to look at situations where either a demand side or a supply side change is going to change our market equilibrium. So the first one is the set of changes that are going to come from the shift in the demand side. So there are usually these factors that shift the demand for bonds, and these are all self-explanatory, so let's just go over them. So the first one is the wealth thing. In the last class we said that wealth is sort of like important for bonds because we assume that our bonds are normal goods. So anytime wealth increases, demand for bonds shifts to the right. Did we cover this in the last class? Okay, very good. But just want to mention and make sure that I'm not repeating anything. So whenever there is an increase in wealth, it's going to shift your demand curve to the right, and it will follow from what we have covered. So if we think about the equilibrium, let's just have one model and just talk about it in that sense. So first of all, when we have an increase in wealth, it is going to shift the demand for bonds to the right, meaning people have more money. If they have more income, they would like to buy more bonds. What it does, it increases the price from, let's say, P star, I star to P1, and it also leads to a new interest rate. But we have to understand that when prices go up from P star to P1, so price will increase, interest rate will go down, right? So an increase in wealth really raises price and reduces equilibrium interest rate. Are we all clear on this? Make sense? Okay. So that's number one. Number two is kind of critical. So number two is this idea of expected returns. So what is an expected return of a bond? The expected return of a bond is usually written like that. So let me rewrite this so that we understand. When we think about expected return, REI, expected, can you just see from both sides? Or do you prefer that I write it in a Word document? The handwriting is not going to be that good. Board is always more convenient. Is it more visible? Okay. So what is REI? REI is the rate of return or expected return on an asset. We saw that in the last chapter. So it is that CT plus divided by PT plus, this is not the important part. The important part is the growth in the value of the asset. So it's the second component that is important to us. So I actually have written it down like this. So that's my real, expected rate of return, and I want to now understand how, if this changes, how does it affect the market, right? Okay. So let's read the explanation. So we are saying that higher expected return in the future lowers the expected return for long-term bonds, shifts the demand curve to the left. So a lot of discussion. So let's imagine we expect PTI to go up, right? So if PTI goes up, so I am expecting, sorry, I apologize. Okay, so the one that I want to focus on is this one, but I'm going to start from a different part. I'm going to say that there is an expectation that in the future the return is going to go up. So the interest rate, by the way, I apologize. Somebody mentioned that at the very last part of the last class. When we were drawing all these graphs, the interest rate you are seeing here is real interest rate. I think I think you should all know that, right? So there are two interest rates that we usually talk about. The interest rate, initially when I write the Fisher equation, and I apologize for that, this was my mistake. So usually nominal interest rate is written as the real interest rate plus pi e, expected inflation rate. But when we draw all these modeling, model for the bond market or for the financial market, these i's no longer have the r, and this obviously creates confusion. This I here is real interest rate, because in economics we do not really care about nominal. So any kind of discussion about interest rate in a modeling environment will automatically mean that we are talking about real interest rate. Okay, so if you expect that in the future you are going to have a higher interest rate, real interest rate, that automatically means that in the future the price is going to be lower, because that's how the relationship between the price of a bond and the real interest rate on that bond play out. And if you expect a higher interest rate in the future, you expect a lower price of the bond in the future. As a result, your REI today goes down. Okay? Makes sense? So you are thinking about buying a bond today. You have some expectation that in the future your bond should be giving you a higher interest rate, then that would mean that in the future the bond that you are buying today will have a lower price. That means your rate of return or expected return, RET, is going to go down. So how do you respond? Do you want to buy more bonds today, or do you want to buy less bonds today? Are we all clear on the problem? So this is very similar to how expectation about future affects your current purchasing decisions. In this case, the purchasing decision is about a bond. So if you expect that in the future interest rate is going to go up, price is going to go down, that would actually mean that your rate of return is going to go down, right? Do we all see that from this component, right? So we could argue that if this is the case, the demand is going to shift to the left from D to D2. And you can see that that will lead to something very interesting. That will lead to a reduction in the price and a reduction in the quantity. A reduction in price from P star to PT means that the interest, let's not call it PT, let's call it P3. The interest rate associated with P3 is I3. Now can we say anything about I3 and I star? When we compare I star, which is my original interest rate, when we are comparing I star with my new interest rate I3, can I compare between them? Anyone?
Could you repeat the question?
Okay, so there was I expected that in the future my interest rate is going to go up. That means that in the future the price of my bond is going to go up, which means that my rate of return is going to go down today. So my demand goes down. My demand takes a leftward shift. As a result, my equilibrium moves from, let's say, A to B. A was my original equilibrium. My price was P star. My interest rate was I star. At the new equilibrium, my price is P3, my interest rate is I3. I know for sure that my P star is greater than my P3, which means that my price of my bond has gone down. What can we say about the interest rate?
I3 is bigger than P star.
Okay. I3 is bigger than I. That's absolutely right. What just happened? What just happened? Oh, they are, but what did just happen? Can anyone tell me? Please take a look at the experiment. I expected in the future my interest rate should go up. As a result, prices should go down. In the future, in T+1, I take decisions today. What has that done? It has reduced the price today and raised the price interest rate today. Do you all see that? Do you all see that? Why? What is this called? This is a very, very important economic phenomenon, which is called, as has a very strange name, it's not in your book, it's called self-fulfilling prophecy. One of the few things that really makes economics such an interesting area to study is one of these. Self-fulfilling prophecy refers to economic events where your actions really becomes consistent with your expectations. What you expect forces your decisions, and your decisions act out in such a way that your expectations are fulfilled. So in that sense, you are self-fulfilling your expectations or prophecy. Prophecy means expectation. In economics, prophecy means just forecasting. It has got nothing to do with religion. Okay? And this is a fascinating experiment. Although